Hey guys, just want to give you your quick last lesson from this chapter, about graphing radical functions. So I've got 3 examples for you, and we'll start with the very first basic one, which is just that y equals the square root of x. And if we were to create a t-chart for it, right? Let me get my marker here. Creating a t-chart. Let's go ahead and plan this out, I guess. Let's go over here. And I promise to start soon. Here we go. Create a t-chart for this. X and y, right? So what does x have to be in order for us to use a square root, right? So we can't put a negative in there. Can't do the negative square root of a number. It's just going to give us an imaginary number. We'll have to start with 0, right? We can do the square root of 0. Square root of 0 is 0. So our first point on this graph is going to be at 0, 0. Right here. Get a different color for my points. And then you have to think about, well, what else can we do the square root of? We can do the square root of 1, which is 1. We can do the square root of 4, which is 2. Square root of 9, which is 3, right? So what does a general y equals the square root of x graph look like? And I'm going to go ahead, why not? I'll use red. So we have x is 0, y is 0, right? We have x is 1, y is 1. We have x is 4, 1, 2, 3, 4, y is 2. And then 9 and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be over here someplace, right? Right in there. And what you get is this graph like that. Okay? So just arc there to the right, right? Now, remember that with a square root, you can have a plus or minus answer, right? So generally we just are looking at the graph that you see right there in front of you, right? But if you think about if we were to do the negative as well, then you would have the negative answers for these. Your graph would start going this way. 1, negative 1, 4, negative 2, like this, down this way. Okay. If we were to include the negative answer. So basically it's like a parabola that fell over. Like a parabola. And that is. It's not is a parabola. It's like a parabola that fell over to its side. Right? So that's what the general graph of a y equals the square root of x looks like. So now if we were to mess around with this and try something else. If we were to go with this now, y equals the square root of x plus 2. So now we're adding 2. So notice the plus 2 is outside of the radical. So you're doing that normal graph, but now we're just going to add 2 to it. So that's going to change it's going to shift it up, right? So normally when x is 0, y is 0, but now when x is 0, y is 2. So x is 0, y is 2. So when you're adding or subtracting things on the outside of the radical, then you're shifting it vertically, up or down, right? So when x is 1, y will be 3. When x is 4, y will be 4. 1, 2, 3, 4. 1, 2, 3, 4. All right? And your graph just shifted up. It's the same shape. It's the same look. It just shifted it up from where it was, right? Because we added 2. If we were subtracted 2, then we would have shifted down. So that starting point would be at 0, negative 2. All right, we'd be shifted down. So it's the same shape, we just moved it up 2. Every point moved up 2. All right, now let's talk about when we have a number underneath the radical with the x, right? So now what that's doing, it's shifting where the 0 starts, right? So when x is 0, y is going to be negative 1. Well, that doesn't work for graphing at the radical, right? When x is 0, Well, that's a terrible x and y. I'll focus now. When x is 0, y is going to be I, right? The square root of -1. Well, we can't graph that. So what does x have to be in order for our radical to be 0? Well, in this case, x is going to have to be 1. So when x is 1, y will be 0. That's our starting point now. Now we're shifting right and left. So when we are adding or subtracting something underneath the radical, that's when you're shifting right or left. So in this case, when we're subtracting, we're shifting right. X is going to have to be 1 in order for us to have our starting point with y being 0. So now we have to think about, I can do the radical of 1. In order to have the radical of 1, x is going to have to be 2, 2, 1, and then it's going to be 5, 2, right? Because 5 minus 1 is 4, square root of 4 is 2. So now we've shifted our graph. It's going to be the exact same shape. It's going to be 1, 0. Right there, it's going to be 2, 1, 2, 3, 4, 5, 5, 2. Same exact shape as the first two, except now, oops, now we are shifting the graph right. So when you're adding or subtracting underneath the radical, that's when you shift your graph right or left. All right? Now, one last example. And go over here to the 3 times the square root of x. Now, when the 3 is outside the radical, that means we're expanding, we're stretching the graph. Okay? So when you think about this, you're stretching the graph. You've got, when x is 0, y is going to still be 0, right? That's still the same origin starting point. Origin story is right there at the origin, right? So now, though, when x is 1, square root of 1, y is going to be 3. So now, see, we shifted that up. When x is 1, y is 3. When x is 4, square root of 4 is 2. 2 times 3 is 6. Now we're going to have y as 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So now, it's hard to see, but the shape is the same, but we've stretched it. So it's bigger, right? Stretching it so it's taller, so it's looking a little weird, but it's still the same shape. All right? So, let's recap. Recapping. So if you look at the first example, that is your general y equals the square root of x graph. All right? 0, 1, 4, and 9 be the first ones you would use. That's your general shape right there. Right? Then when you add 2 and it's outside the radical, we've shifted it up. Right? Same shape, we just shifted it up. We changed where it is. When we subtracted underneath the radical, it shifts it left and right. In this case, we subtracted, it's going to shift right. If we added, it would shift it left. And then when we multiply, right there, when you multiply, that's stretching it up. Now, if we multiply by 1/2, it would kind of like shrink it down, make it smaller. All right? All right, guys, I hope that helps. The assignment is listed in the post above or below the video. I hope this helps you guys with your graphing. That looks kind of funny now. Anyway, and with this assignment, we'll be testing on Thursday. Bye, guys.